explain what is meant by the gradient of a straight line. Now we know that the standard formula for a straight line graph is y equals ax plus q, where q is the y-intercept. In other words, that's the point at which the straight line passes through the y-axis. And we have a as the gradient. We also know that we can find the gradient on a graph by saying y2 minus y1 over x2 minus x1, where you might have 2 points and you need to find the gradient between those 2 points. You can simply substitute the x and y values into this formula to find the gradient. But what is meant by the word gradient? Well, let's take a look at a typical example or an analogy to try and explain this. Let's say this boy is climbing up a hill. Now we need to find a way to define the steepness of this hill, because he starts from a point A and he reaches a point B. And if the hill was very steep, he would climb more difficult than if it was less steep. So we need to find a way in order to define the steepness of this hill. And to do that, we say, by the time he reaches point B, he has covered a certain horizontal distance away from A, and he has covered a certain vertical distance away from A. So we can say that's the vertical distance and this is the horizontal distance away from point A. And that line that he has walked from A to B is the steepness that we are looking for. And to do that, we define a fraction which we call steepness. And we say that steepness is the fraction of V divided by H. Now you can think for yourself. Let's say there was a point there, C, and the hill was actually that steep. Obviously, I mean, you can see that the hill AC is a lot less steep than the hill AB. And if there was another value there, we would get a totally different fraction for V divided by H. So it's very important. Steepness is defined as a fraction, and the fraction indicates the vertical distance covered from one point to another divided by the horizontal distance covered from one point to another. And instead of saying steepness, we can call this gradient. And if you now look carefully at the formula for gradient, you'll see there it's the difference between 2 points vertically divided by the difference between the 2 points horizontally. That then gives us a definition and an explanation for what is meant by the word gradient. Now when we look at a typical straight line graph, you just need to also understand this is specific to graphs. If that is your x-axis and your y-axis, and you have a straight line graph going like that, from bottom left to top right hand corner, this graph has a positive gradient. If it was lying the other way, like that, it would have a negative gradient. If this line was perfectly horizontal, in other words parallel to the x-axis, it would have a 0 gradient, and if this line was perfectly vertical, it would have no gradient. Those are the 4 types of gradients that we can encounter on a specific straight line graph or on an axis diagram, and you need to know the difference between them. So if we are required, for instance, to draw a graph of, say, the function y equals 2x plus 3, already we see that the gradient, the 2, is not a fraction. But remember, you can write it as 2 over 1. So immediately you have the vertical displacement divided by the horizontal displacement. And if we then draw an axis diagram in order to draw this graph on, we can start. This is a specific technique called the gradient intercept method. We start with the 3 on the y-axis. And then we have a vertical displacement of 2. Now we can go down 2 or we can go up 2. Doesn't really matter. And normally it's just a better idea to go towards the origin. But it's no rule as far as that is concerned. Point is, you need to go 2 down, and now you need to go 1 horizontal. Now if you go 1 to the left and you make a dot and you then connect those 2 points with a ruler and a pen or a pencil, you've got your graph lying in the positive direction, which we knew initially there was a plus in front of the 2x because there wasn't a minus. Simple as that. If there was a minus, or if it was supposed to be a minus, there would have been a minus. Now if we decided to rather go up, then we had to go 1 to the right, because ultimately once we are done, the straight line needs to lie in the right direction. That is very important. The positive gradient needs to lie from bottom left to top right. So whether you go 2 up or 2 down doesn't matter. The only thing that really matters is when you go left or right will depend on the sign of the gradient of the specific graph.